Hello everyone, today we are going to discuss Ohm's law and failure of Ohm's law in some material. So first we will discuss Ohm's law. So in 1826, George Simon Ohm discovered that if we put a physical condition like temperature, mechanical strain, etc. of conductor remain unchanged, then the current flowing through a conductor is always directly proportional to the potential difference across the conductor. This is known as, or this law is Ohm's law. So here what will happen? In 1826, George Simon Ohm discovered that if we put a physical condition like temperature, mechanical strain remain unchanged of conductor, then the current flowing through this conductor is always directly proportional to the potential difference across the conductor. So here we can say that this V is the potential difference, I is the current which is passing through the conductor. So voltage is directly proportional to the current. So V is equal to Ri, where R is the resistance, which is the proportionality constant. So R is equal to, we can write V upon I, that is the potential difference upon current. So resistance in conductor depends on nature of conductor. If we have changed the conductor material, suppose we have, first we will take the silver, then we will take the mercury or any other metal, so we can say that the resistance is different for different material. So nature of conductor, the resistance is depends on nature of conductor. As an insulator, the resistance is more, in conductor resistance is less. So that is depends on nature of conductor. Dimension, if we change the length or cross section area, then the resistance may be different for different length or cross section area. Physical condition of conductor, suppose we have changed the environmental condition or we have applied some strain on that conductor or surrounding temperature changes, the resistance also changes in the conductor. So ohmic conductor and non-ohmic conductor. The ohmic conductor is also called as linear conductor and non-ohmic conductor is called as non-linear conductor. So why it is called as linear or non-linear conductor, or ohmic or non-ohmic conductor? So here what will happen? In a material which obey the Ohm's law very well, then that material is called as ohmic conductor. So those material which obey the Ohm's law very well, that material is called as the ohmic conductor or linear conductor. Suppose we have plotted the graph current versus potential difference. That graph is straight line. That graph is straight line. So we will get only one value of slope. So straight line passing through the origin as shown in figure A. Here what will happen? We will get the straight line. Here we have took the current versus voltage, or voltage versus current. We will get the straight line graph. So that I is proportional, V is directly proportional to the I, or I is directly proportional to the V. So here we will get the only one value of slope, or reciprocal of slope is resistance. So we will get the resistance is constant. Example is silver, copper, mercury, etc. are the example of ohmic conductor. And in non-ohmic conductor, non-linear conductor, in linear conductor we will get the straight line graph. In non-linear conductor, in such cases the graph I versus V, current versus potential difference, is not straight line, not straight line. So we can say that as shown in figure B. So we will get in curve manner graph. So here suppose we have calculating the slope here, we will get the different value. Suppose we have calculating here, we will get the different value. So at different point we will get the different value of slope. So resistance is not constant, because reciprocal of slope is resistance, and resistance is different for different point. So resistance is not constant. So we will get the curve manner graph, not straight line. So that's why it is called as non-linear conductor. Example: crystal rectifier, gases, harmonic valves, transistor, vacuum diode, etc. In this way, we will get the curve manner. Resistance is not constant. Failure of Ohm's law. Now we will discuss failure of Ohm's law. So Ohm's law in resistor. Suppose we took the resistor. Here we have, in this circuit, we have connected the resistor. This is the potential difference. This is positive terminal, this is negative terminal. Here we have to put the variable battery, and this ammeter is measure the current. Suppose we have changing the voltage respect to current is also changes. If we have changed the voltage of battery, the current is also proportionally changes. We will get the straight line. So here we will do voltage versus current. As the voltage changes, current is also proportionally changes. So we will get the straight line, and here we are calculating the slope. So we will get only one value. So we can say that the reciprocal of slope is resistance. So only one value we have get of the resistance. So this obey the Ohm's law in forward bias as well as in reverse bias. Suppose we have change the polarity of the battery. Suppose we have changed the polarity of the battery. So here is the negative terminal, here is the positive terminal. This is variable battery we have connected. As the voltage changes in reverse direction, current is also changes. So we will get the straight line, and we will get only one value of resistor. So resistance is constant. So we can say that in resistor Ohm's law is obeyed. In resistor Ohm's law is obeyed. Suppose we have took the vacuum diode. So in vacuum diode, here we have connected the positive terminal, here we have connected the negative terminal. Here this is the cathode, this is the anode. Here is the heater, that is due to the heating, thermonic electrons are emitted and they will attract toward the anode. This is the anode, this is the cathode, and different value of voltage we will measure the current, and we will get the graph in curve manner. So I is directly proportional to the v to the power 3/2. So we will get, due to the non-linear curve, we will get the different value of slope. So different resistance is there. So resistance is not constant. So we can say that in forward bias Ohm's law cannot obey, does not obey. Similarly, if we have changed the polarity of the battery, if we have changed the polarity of the battery, so here in forward bias we will get in this type of graph. In reverse bias we will get very small amount of current in this way. So here what will happen, here we have connected cathode, here is the anode, here we have connected the heater for harmonic emission. So in this way we can say that the current is flowing, so small amount of current is flowing in this way as a potential difference changes. So we will get the graph is non-linear. So resistance value is not constant because slope is different for different points. So we can say that the vacuum diode does not obey the Ohm's law. Does not obey the Ohm's law. Now the Ohm's law in semiconducting diode, that is the p-n junction diode. So in p-n junction diode, so this is the battery, this is the positive terminal, this is the negative terminal. So this is the p terminal, this is the n terminal. So this diode is connected in forward bias, and once we are varying the voltage respect to current, we have measured by using ammeter. So we will get the graph. We will get the graph in curve manner. We will get the graph in curve manner. So slope is not constant, resistance is not constant because slope is different for different point as this curve point. So we can say that in forward bias the semiconducting diode do not obey the Ohm's law. Similarly in reverse bias, suppose we have changing the polarity. This here is the negative terminal of the battery, here is the positive terminal of the battery. Just we have changing the terminal of the battery. Now this dark p-n junction diode is connected in reverse bias because this p is connected to negative terminal, N is connected to positive terminal, here P is connected to positive, N is connected to negative. So this is the forward bias, this is the reverse bias. So in reverse bias, the current is passing curve manner in this way. So here is also the, we will get the different value of slope or resistance. So we can say that the semiconducting diode which do not obey the Ohm's law, vacuum diode also do not obey the Ohm's law, but resistor obey the Ohm's law, silver obey the Ohm's law, mercury obey the Ohm's law. So we can say that semiconducting diode does not obey the Ohm's law. Thank you. If you like this lesson, please like, comment and subscribe this channel. Thank you for watching this video till to end.